All right, guys, I'm back. So, like we said, most atoms or most particles are neutral. So, how do they gain a charge? How do they become negative or positive? Well, what happens is an electron can leave one atom and be attracted to another atom. So it's kind of like magnets. We talked about magnets having like poles. So with a magnet, opposite poles attract. The north pole is attracted to a south pole. Well, with the atom and our electrons and protons, a negative electron is attracted to a positive proton. So sometimes these electrons can leave this atom and be attracted to another atom. And once they leave, once it loses one electron, its charge goes from neutral to a positive charge. And if this electron goes to another atom, that atom that was once neutral now has a negative charge. So if it has more electrons than protons, it has a negative charge. If it has more protons than electrons, it has a positive charge. So electrons have a negative charge and protons have a positive charge. And that's what this is saying right here. Charges are like magnets. If they're the same, they push away or repel. If they are opposite, they attract or pull together. In the same way that opposite poles on magnets attract and like poles repel. Now, electric charges can build up on objects. This buildup is called static electricity. Static means not moving. So when we talk about static electricity, that means electrons that have built up on your body and they're staying there and they're not moving. Remember, electrons can move from one atom to another, making whatever they move to negatively charged. As you walk across a carpet, electrons move from the carpet to you. Because electrons repel each other, they spread out all over your body. When you touch something, the electrons jump from your finger to the object. This jumping is called electrostatic discharge. You feel it as a tiny shock. So here's just another picture just showing you how if they're opposites, they're attracted to each other. That's why the arrows are pointing in. If they're the same, then they push away or repel. And here's something showing you how you get you get the little shock sometimes you feel when you touch something that's metal. Metal is a good conductor, so it's going to allow that energy to flow through it very easily. Now, not all electric static discharges cause small shocks. Some result in huge shocks. During a thunderstorm, tiny raindrops or ice particles bump into each other. These collisions cause an electric charge to build up in the clouds. Positive charge form at the top of a cloud and on the ground, and negative charges form at the bottom of the cloud. When a difference in charge between a cloud and the ground is great enough, there is a huge electrostatic discharge that we call lightning. A lightning spark can jump between two clouds, between a cloud and the air, or between a cloud and the ground. The temperature inside a lightning bolt can reach 27,000 degrees Celsius, which is hotter than the surface of the sun. So, again, what's happening is these ice particles and raindrops are bumping into each other here in this cloud, and that causes this these negative electrons to build up at the bottom of the cloud, and they are attracted to positive electrons that are on the ground. And that's what lightning is. So lightning is just a bigger form of electrostatic discharge that you might feel when you're going down a slide and you feel and you get shocked when you get up. That's just an electrostatic discharge. All right, so that's all for this lesson, guys. I'm going to have a few review questions for you to answer. If you have any more questions about this topic, just send me a message, and we're going to pick back up on this here in a couple of days and continue to figure out what's happening um, with electricity.